Uh, and Bob has volunteered to. Bob has volunteered to give a presentation that he'd given a number of years ago on the forensics. He's doing it short notice. If you look in your thumb drives, you'll see a alternate for the presentation today. He's stepped up to do this and didn't have a lot of wording on it, so he did not get a chance to really run through it. But the information he supplies is always excellent, and he'll probably tell you where, well, this is maybe a little dated and stuff like that. Oh, we need to turn that back on.
Is this
yeah, that's it. Let's see if the on button's on. I think we need to hit the button right here. Okay, should be good to go. So let's see, what else we have going? We talked about the food over there. Anybody have any specific question while Bob's getting set up here? Nope, okay. We'll do the drawing tomorrow right after lunch. And I've been trying to ask, Mark loves to do everything. I don't know if he wants to be an auctioneer or not, or do we want to do a silent auction?
I just told Bob if he gets done early, that
no worries.
It's a blessing to me.
Yeah. Yeah.
What do you want me to auction off?
The Dumb Horse tomorrow. No? We can do a silent auction. Okay. Bob, I guess we'll turn it over to you.
Okay.
Again. Thank you.
Well, I'm glad Ron told the truth, and now I will add to the truth. This was a short notice step up to fill in for our friend Steve Pecklick, who's a really fine forensic engineer and has done this presentation alternating with me going way back. He did the most recent ones, but he's ill this week, and so I agreed to step in. So some of the stuff that you're going to see is a little stale because I didn't have a chance to redo the whole thing. I pulled it out of my archive, and hopefully there'll be some useful information in it, but I'm not going to dwell on it too much. So we're talking about forensics, and when you hear forensics, it means something went wrong. Something's not what it should be. So every time you hear forensics or forensic testing, you should, in the back of your mind, hear the CSI, da-dump, before you start thinking or working in the field. So you go to say, da-dump, where's the crack? Da-dump, where's the leak? Something's wrong. And the way to find out what's wrong is observation and inspection that we're talking about now, but also testing, specific testing. Testing has several roles, one of which is quality assurance, and I'll define this during the program. Another of which is diagnostics and forensics. And an introduction, I would introduce you to EDI's moisture analysis program. Okay, testing in the EIFS world is evolving, and I can say that with firsthand knowledge because I participate in ASTM E55.58, which is the subcommittee covering EIFS. And I've been on that committee for about 20 years. And if you think over 20 years there's consensus on how this is going to happen, forget it. There's another 20 years. I've been in ASTM since 1985, and we still don't have a definitive definition of a leak. That's the nature of ASTM and the testing that goes in. But there are some things on the table that we work with and understand that they're evolving. EMA, which is the EIFS Industry Members Association, it's the umbrella group for all the manufacturers, now has ANSI status, American National Standards Institute status. So stuff that they publish now has a standards parameter. That's not ASTM, which is a consensus standard. ANSI is an industry standard, different. ASTM E058 welcomes people interested in EIFS to participate in their work. I would encourage anyone. I learned more at ASTM when it comes to building science and forensics and leakage than was ever available to me in school when I was in school. You gather and you work with peers, and there's nothing more valuable than that. And then the peers gang up on the manufacturers, and the manufacturers push back on the peers, and we all have equal votes. So that's not an easy path to consensus, but when you get there, you've really got something that becomes meaningful because there's so many inputs to get there. So if you want to participate in something meaningful in the EIFS world, I would recommend ASTM, EO6.58. 58 is the subcommittee. EO6 is the main committee. Testing in the EIFS world. Several. Product and system development. The manufacturers go through this constantly as they develop new materials and new approaches and systems. They have to produce research reports, qualification reports, ES reports, evaluation reports, to get their products accepted as a code-compliant material, and that results in reports to the code bodies that you can get copies of, and they describe the system in detail. They have to. The testing is also done for quality assurance and quality control during the construction phase of a job, typically a bigger job. It's also used for diagnosing problems when stuff doesn't go correct. That's when you hear the CSI Tadum in the back of your head. And they are all similar, they're all similar procedurally and equipment-wise, but they all have different purposes, and the protocols vary with the purpose of the test, even though you're using the same test. In product development, they look at material properties of the components. Now, do you care particularly about the material properties of the components? Individual, do you need to know the polymer content of what's in the bucket? Do you need to know the tensile strength of the mesh? Do you need to know the compressive strength of a cube of the cement that they recommend you put in? No. What's important about these kinds of tests, component and material tests, is consistency. That once they declare what their product is, you can verify that you're getting a consistent product in their product line. And the product will not be the same. The properties of the product will not be the same from all manufacturers. They'll all have different tensile strengths for the mesh. They'll all have different polymers in their materials. They'll have different primers and the like. But once you're in a system and they declare the properties of their system components, it's testing that verifies you're getting what you're paying for. Compatibility with other components, and this is important because you've already heard that components from different manufacturers should not be mixed. And so what's the harm? What's the harm? Isn't a mesh a mesh? Isn't a base coat a base coat? Well, no, it's not. Things have to stick together. Things have to work together. The base coat has to stick to the EPS board. There are pre-qualified EPS boards that work with a manufacturer's base coat. That's all tested in a lab. And mixing those two components sort of defeats the whole purpose. Makes it a non-system, makes it a happening. Then you might as well go to Lowe's or Home Depot and buy a bunch of buckets of stuff. I've been on that job. And just put it on the wall somehow. The manufacturing consistency is for them so that bucket to bucket is consistent, that they know what's going out the door is consistent to what they said it was going to be. And it gives them a competitive position. And this is always been interesting to me. Bond strengths are advertised as a product property. Okay, so some products advertise their bond strength as 36 psi between the base coat and the EPS. And others only say 30 psi. PSI. What does that mean on the building? What possible difference can that mean? A 36 PSI bond strength on a square foot of wall is like 3,600 pounds of force. No wind is going to do that. So is it 3,600 or 1,600? 1,600 pounds. So what's the difference between 36 PSI and 30 PSI in a matter that makes a difference for a project? None. But one guy gets to report 36. So he's 6 PSI better than the other guy. It's a manufacturing property. It's used for a marketing advantage of no consequence in the performance of the system. And it aids in complying with codes, because when you get an evaluation report accepted by a code body like the IBC or the IRC, then those components have to be consistent. They have a right to expect that your components perform as reported in the S report. And data provided, these things, manufacturing tests, provide a datum for in-place field testing if it's appropriate. Quality assurance and quality control testing is a different story. They're two different things. My understanding is quality assurance is an overall program to conduct, administer, and document quality control activities. And quality control are the actions required by a quality assurance program. In other words, quality assurance is the big picture. Quality assurance is not a particular test at a particular time. Quality control is that particular test at a particular time as part of a quality assurance program. The program is executed to assure quality. Quality control is executed to assure compliance with quality assurance. Okay? And quality control can be a variety of procedures, like if you're reviewing shop drawings, doing review of product submittals, inspections, testing, disassembly. All of those components are quality control components which go into an overall quality assurance program. Whose responsibility is it to declare what the quality assurance program is? Is it the inspector? The designer of record. And what if there is no quality assurance program? Then what? Yeah. Well, it's time to speak up. It's time to seek clarification by asking. You have to be like Tucker Carlson at this point. You have to ask a question that has no answer to motivate action on the part of the designer of record. Like, if there's no quality assurance program, you say, how often should I do the quality assurance testing? That's a lead-in question. Then the next question is, what quality assurance testing would you like to include in this program that you don't have in your design document? And work your way through it that way. But it's not your job as an inspector to establish that program. You can do it through your contract with the designer of record or your contract with the owner, but you can't declare it in a vacuum. And typically you will execute it in compliance with the design documents. Here are the ways not to look at a quality assurance program. One method of getting quality assurance is to pound on the table and say, this better not leak. Okay, well, that's, in some people's view, a quality assurance program. And the other is, well, you, whoever you are, whoever's at the end of my finger, make sure everything is okay. You know, the classic specification for an architect of little skill is cut to fit, patch to match, contractor make nice. That's that quality assurance program. And if this leaks, I'll have your whatever. Those are intents and aspirations but they are not quality assurance programs. Procedurally, the program has, by definition, a scope, a frequency, a pass-fail criteria. Sometimes those are defined in the test procedure itself. Sometimes the test procedures just describe what to do, but not what is a pass and what is a fail. Access, patching, and payment has to be part of the program. If you need to be on a swing stage or a scaffold to execute your quality assurance program, that needs to be in the program. Who pays for that? Who pays to provide access to the inspector, access to the testing agency, access to the people executing the quality assurance program? And if you have to make a hole to do it or anchor something to the building, who pays to patch that? Certainly not the inspector. So that all needs to be defined before you sign on to a program. And what's the reporting? What's the extent of reporting? And Scott will show you a good prototype for that. And what are the qualifications of the person executing the quality assurance program? What you're doing here today is part of gaining that qualification. Not any Yahoo should be out there doing quality assurance testing on a building, particularly a large sensitive building. So some examples of this. From the inspection point of view, what's the procedure? A checklist will describe that. What's the scope? Well, what's going to be part of the assurance program? The EPS, the lamina, the sealants, the windows, the flashing, whatever's got to be looked at. What's the frequency? You can say 6 site visits, a site visit every 3 weeks. For the duration, a site visit every 2 weeks until the roof is on. Whatever it is, it needs to be defined. Otherwise, you're just swimming. And who pays for access, patching, and payment? Typically the owner through the GC. And reporting is a letter report to, and who gets it? If you're employed by the owner, should the contractor get your report from you or through the owner? If your client is the owner, your report goes to the owner. And what are the qualifications? Well, EDI is one of the meaningful qualifications for an EIFS-related quality assurance program. And there are others. AMA has a qualification. Masonry World has, for reinforced masonry, has a qualification. Welding inspection has a qualification. All that stuff. There are qualifications for the different technologies. In terms of testing, what's available for a quality assurance program in the world of EIFS? For overall testing, we have ASTM E1105. If you don't have a copy of this, you should get one from ASTM. I think it's like $35. It's full wall testing, post-construction, different from laboratory testing of a product. This is for the wall itself in place. The scope, 2 sections of wall, with or without windows, 10 sections of walls. The first 1% of wall, the first window needs to be defined. Otherwise, you don't know when to be there to do your work. What's the pass-fail criteria? Typically, it will be no uncontrolled. This is a trap, because I want to caution you that the ASTM water testing procedures have an intense and adverse influence of manufacturers. And they have constrained the usefulness of these so that, for example, 1 ounce of water is okay if it leaks. Now ask your owner, do you actually want to see 1 ounce of water on your window? Is that what you thought you bought? What gets tested? Only a window unit, according to the manufacturer, gets tested. When they qualify a system in the lab that requires jam receptors and head receptors, those are not included in their laboratory test. When they report to you, this is an 8-pound window, it resists 8 pounds per square foot of pressure during a water test. It did not include the head receptor and the jam receptors. Now, can it go in the building without those? No. What if the head receptors and the jam receptors don't behave like the window does, or the sliding glass door. So who takes care of all of that? This is where it gets taken care of in the definition of the pass-fail criteria. And here's what I recommend to you. If it's a construction phase, quality assurance E1105 test, it's shortly after fabrication and installation, it's fair to test it at the full rated pressure for water infiltration. If it's been in service for a while, you're doing a diagnostic or forensic test after the fact, the window's been in use, it's fair to test it less than the rated capacity. And the AMA recommendation is 2/3 of the rated capacity. So if it's a 12-pound product, like a curtain wall, and qualified at that and was put on the building, after a period of service, which is undefined, it's fair to test it at 9 PSF. Because being in service has an impact on the product. But how do you know? That has to be defined. What you don't want to do is be hammering this out during a test, because that makes the whole thing a waste of time. If it passes, everybody's happy. If it doesn't, that's when the dispute starts. What was the right pressure? And how much of the window needed to be included in the test? You mean you tested the head receptor? That's not part of the system. Well, in my building it is. If it's not part of the system, take it out. Where do we go from there? Now I'll test what's left. You want that? No. So it needs to be defined in the quality control. And our preference is, and when we do it on our jobs, we define that in the project specifications. So the QC people don't have to battle this out. The battle is already fought, and when a contractor submits a contract to supply, this is all baked in. There's no dispute follows that. And if they don't want to meet those criteria, don't bid this job. If it's not in the project specifications, there's room for dispute that needs to be nipped in the bud, and this is the time to do it. Okay, the scope of testing. There's two kinds of testing. There's subsystem and component quality control testing. Individual test is not a quality assurance program. It's a quality control activity. So how much gets tested? There's subsystems. You can do the window only, the eaves only, a variety of tests just for eaves. You can do the masonry, the roof, all kinds of individual components. Those are good for consistency with the project specification for the products that are delivered. And then there's subsystem quality control testing, which is broader in scope. That would be a whole section of wall, story high, a couple of bays, a bay wide, or a bunch of gang windows, a bunch of strip windows with spandrel and sill included in there. It's more than just a test of the windows, but it includes all the places that you're really interested in. The interfaces between the different components of the wall, the integration of the different components, how the WRB integrates with the window frame, integrates with the flashing, integrates with the window, and how they interact. And I always have this idea that the building's got to be weatherproof before you put the cladding on. So even if it's not a standard in the test that you're going to be paid for, I like to go out and squirt things before the cladding goes on, before the masonry goes on, and make sure that the windows are integrated properly with the WRB, not with the bricks. It's already too late by that time if you're only looking at how the windows are sealed to the brick. Diagnostic testing for forensics it can do a couple of things. They can compare system performance on different parts of the building. This part is successful. This part is unsuccessful. This part was done by Joe, good guy. This guy was done by Charlie, a real lacquer. How do you hold Charlie accountable? You compare his work, which follows the same design criteria as Charlie's, compare it to Charlie's achievement. Compare system performance with an absolute requirement, which has to be specified or has to be part of the product declaration. Like, this is a 6-pound window. Okay, so we tested the 6 pound. Doesn't matter what that other window, which is a different window, does. This one has got to do 6 pounds. That's an absolute criteria. And then they become forensic if they don't work, and you need to determine the cause, the extent, and the significance of a problem. This is not inspection. Inspection is a observe and report process. This is diagnosis. This is test and understand causes of non-performance. And two things, well, I'm going to get to standard further down. The role of testing in an evaluation of a building. For a known problem, a building that is known to have a problem. What is the performance history? What do the project documents say? And focus on inspection and observation. The answer is not going to be found on paper. A clue can be found on paper, but the answer is from observing and inspecting the building itself. And one of the things to observe is the building built according to the drawings? Is what you think you got, according to the drawings, what you actually got? And what I've done many times in the past is make a half-tone copy of the design drawing, cross-sections and the like. Half-tone, so they're grayed out, and then I go out in the field with a felt tip marker and I draw the actual conditions. And you compare the half-tone background of that sketch with what's actually there, it's astounding how different they can be. And sometimes that difference points to a source of a problem. And then analyze, of course, what you've got. Then do some testing to verify your findings. And verify your findings. Okay, this is a standard in ASTM called E2128. It's a standard guide for the evaluation of leakage through building walls. And it's a protocol for evaluating a building that is known to leak. This is not quality assurance. This is diagnostics. I wrote the standard. It took 12 years to get it through ASTM, and it still has an ambiguous definition of leakage. But it's really straightforward. And the reason I spent a chunk of my life doing this is because as inspectors in the EIFS world and consultants, you are going to encounter cowboys. People have no business offering opinions based on their knowledge and experience. Well, how do you hold them accountable? How do you distinguish between your work as a conscientious professional who follows a protocol that's been consensus approved and accepted by a body of peers through ASTM, including manufacturers, from some guy who does a drive-by or diagnoses a leak by the laying on of hands? So now there's a document for accountability. Say, I did this, you didn't. So my finding is more meaningful than your finding, and you're a jerk. Well, you don't have to say that. But it creates an instrument that allows conscientious evaluations to be made and justified and defended against yahoos. And that was worth 12 years of my life. Let me just say one more thing about this. It's very simple. It's very thick, but it's actually very simple. There's only 4 tenets in this, 4 main tenets. One is the evaluation be thorough, that it be systematic, that you don't avoid things in an unconsidered way. It doesn't mean you have to do everything, but you have to consider what you're doing and only not do things that you've considered not necessary to do because of the problem at hand. That's thorough. 4, don't mistake a deviation as a cause of a leak. Just because something is not what you expected to see or not in the design doesn't mean it's the cause of a leak. It doesn't even mean it has to be fixed. It's just a deviation until 4, you've verified that your theory of the cause of a leak is actually the cause of a leak. And how do you do that? Testing. At that point, once you've verified the cause of a leak, then you can start a discussion on repairs and remediation. But finding a deviation does not entitle you to demand a correction to comply with something that's not relevant to the issue at hand. That's up to the owner to do.
A lot of times deviations are corrected through RFIs or request verification. The architect will put it as records and make a change, but it never makes it to the design.
There's lots of reasons for deviations. Yeah. That's if you're tracking back through the history. And knowing the history is worthwhile. But the observation of a deviation in and of itself is not the determination of a cause of a leak. It's simply an observation at that point. And only with verification through testing or exercising it with simple flood tests and the like, is it then a verified cause of a leak that requires remediation. It's really very simple. So if a building is known to leak, and 2128 is only for buildings that are known to leak, it's not a quality assurance program, it's a forensic program. And there's reasons for that distinction. But there are places, the customary places where things leak. Typically, I mean, this is the history of building, of our profession, of our trade. There are customary details like cladding, windows, roofs, decks, penetrations. There are construction practices which are adverse or advantageous, depending on how they're executed. There are manufacturers' recommendations. There are project plans and specifications. This is how the buildings happen. What are the usual suspects for a leakage location? You should know these. You know, where do you start looking? You don't look everywhere. There are places to focus. Windows and doors around and through. Decks, balconies, stoops, and porches. Stoops. That gives away my New York roots. That I think I was told that word is not used any place but New York. But it's the front steps. It's from the old New Amsterdam days of New York. Roof and wall intersections, kickouts, utility penetrations, and so on. There's a whole family of customary, usual suspects.
And I have to point out, because I've seen people do DT where they know that there's water intrusion and they'll chase the leak down. It's like, no, you want to go up and find the source of intrusion. So many times people go up. So to add to that list,
Yes.
chase it up.
Yeah. And to do that, you start at the bottom.
Right.
Yeah. You don't start at the top because you don't know any of the rundown.
Wall and now, oh, down,
Yeah. You always start at the bottom.
know it's gravity, but
Yeah. Here's a couple of examples. Isn't this an inviting wall penetration? Do you think that might leak? That's an east panelized wall. Here's a test setup on a wall. We're building a chamber, an E1105 exterior chamber. It hasn't been erected and put in place yet. We're assembling it on the scaffold there. And we're going to water test it. There'll be a spray rack in there and it'll be pressurized. And then we're going to monitor it from the inside. You see the spray rack inside the chamber. And we're monitoring water infiltration underneath the window. That plywood you see is not the sheathing, that's our chamber. The sheathing is gypsum sheathing below the windowsill. make observations from the interior, not just the exterior, and that might require removing drywall to expose the back of the sheathing. Water traces, water trails, and deterioration. Paint the picture. It's like mining for gold. You follow the dust back to the mother lode. You do the same thing with leaks. I like to cut a little piece of sheathing off from the inside and peel it away so I can see the interface of the sheathing with the lamina. And this is easier to patch than doing it from the outside. And you can see the deterioration. This is an old gypsum sheathing thing that's not even allowed anymore because of this. Tools that we use, there are no specific tools for EIFS testing. These are all adaptations of other fields, window, masonry, and the like. This is a calibrated nozzle. It's described in AMA 501.2. It's got a pressure gauge on it. That gauge is used to control the pressure at the nozzle at about 30 psi. You hold it a foot away from the thing you're testing, and that delivers 5 to 7 psf equivalent pressure on that interface. Not good for any moving joints, only non-moving joints. And it's so easy to use, and you don't have to build a chamber. You can put it on the end of a piece of rod and spray up above where you can reach. So sometimes you don't need a basket or scaffold. You can tape it to the end of a boom and not even be on it. You can control it from the ground and move it around and position it where you want it, and someone's on the inside looking at what's happening. This is my favorite diagnostic tool, and it's so simple. This is what we call a bird bath. It's made out of putty. We create a little putty trough on a feature that we want to investigate. We're not building a chamber. We're not building we don't have to have a Rylom tube sealed to the finish. We don't have to have a big nozzle and pressure at 30 psi, or sometimes you can't get that pressure. It's just a little trough of putty. And here's how it works. You put it on your feature, and in cross-section, this is what it looks like, and you just fill it up with water. And the head of water in that trough equates to the pressure that you're imposing, where 1 inch of water depth is equivalent to 5.2 pounds per square foot. So if you know this wall is a 6-pound wall or a 4-pound wall, you know how much water to put in that trough. And it's so easy. You can do it in corners like this. Is that a consequential crack or an inconsequential crack? Well, you could find out. If you blasted that without masking the windows, if you blasted it with a hose, you don't know if anything you see on the inside is from the window or the eaves. If you can find the wetting to the eaves, you know you're testing the eaves and not the window. Bond strength. This is an adaptation of a membrane test from ASTM, where you glue a metal puck to the surface of the eaves, and you score it around, and then you pull it off. And this is being pulled off using a screw at the top. You just turn that, and this pulls up. And this is a load cell with a strain gauge in it, which reads out the force here. And you could do this with a fish scale or a luggage scale. Just turn that screw and it pops it off. You'll know at what pressure it pops off. There it is, pulled off. And we use a universal joint here, so we're not prying it. So we're always applying only an axial force perpendicular to the surface. Otherwise, prying it would distort the results. We got a great result. What's the failure? The failure is in the EPS board. This never unbonded. The bond is stronger than the board. So do we have a bond problem? No. Here's a way of testing the entire substrate of the entire assembly, the full system assembly, by putting a platen epoxied onto the surface and then pulling it off. Again, using a screw. I mean, we don't have to have fancy electronics. Screws are really great. I mean, it's like a screw jack, basically. And you'll notice there's a distribution of beams here to distribute the force on the platen. So again, we're not prying it. We don't want to pry it. We want to pull axially perpendicular to the wall. There it is. Sealants. How do we test forensically and diagnostically and quality control of sealants? We can check the shelf life, read the buckets. We can look at inspection, surface preparation, cleaning, priming. Does it need to be primed according to the project documents? Do you need to suggest that it be primed? Has it been primed? What primer did they use? All of that is prime. And testing. And here, this is an adaptation of ASTM C794. Cut and pull. It's a pull test. A 2-inch tear test, basically. Here I'm going to inspect a joint for adhesion failure by probing, pushing down the sealant to see if it's bonded to the eaves. And I was doing this on a boom, and the tradesman made a great suggestion to me that I've adopted ever since. He suggested I use a screen roller. It's a little handle with a disc, a 2-inch disc, plastic disc, that they use to roll the edge of a screen into a screen notch when you make a screen. And all you do is you just roll it along the sealing joint, and if the sealing joint puckers away from where it's attached, you know you've got a bond failure. So you don't have to go along, and you don't want to use a screwdriver because you could damage what you're trying to test. That's not the point. So this little screen roller is fabulous. I'm embarrassed that I didn't think of that. There, you can see it. See what does this tell you? It was not an adhesion failure. It was a substrate failure. Someone put the sealant on the finish coat, and the finish coat got pulled off. You see it's stuck to the sealant? So is this the sealant manufacturer's problem, or is this the eaves installer's problem? Both. Should the sealant manufacturer have applied the sealant without going on record that this is incorrect? He should have said, I'm not putting the sealant on until you correct that, and if you got ordered to put it on, so be it. Then whoever ordered him to put it on bought this. This is the cut and peel. The idea is that sealant should not fail. Well, let me go through this. You cut 2 inches of sealant along the bond line as best you can, and then you peel it down and you pull it. And depending on how it fails, if it fails, well, you fail it. You pull it until it fails. And if it fails in adhesion, if it's a cohesion failure, that's what you expect. If it's an adhesion failure, it means it wasn't stuck well enough to develop the cohesive strength of the sealant. There's another example of it, 2 inches. How do you measure the thickness of eaves? This is a plug of eaves cut out with a hole saw. How do you measure the thickness of that? What if you need to know what the thickness is? There's a couple of things you can do. You can remove a plug and measure it with calipers or a micrometer or optical comparator. You've seen those little things with the scale in them. None of them are easy to use because everything is so lumpy and bumpy, non-uniform. Here's the trick I learned. I get a 45-degree carbide tip router bit and I plunge it into the eaves. And it makes a conical depression. And since it's at 45 degrees, the width that I measure with the optical comparator sitting up here is the same as the depth of that layer. So by using an optical comparator from the surface and measuring the width of this layer in the cut, I can determine the thickness of it. It's the same. And by doing that, you sort of average out all the lumpy bumpies, and it becomes much easier to read. Any problem with this? I see some furrowed brows. Okay. There I went around the bullnose. I'm profiling the thickness. And it's important in that whoever troweled this troweled it too thin. Here, they pulled the trowel down too hard on the rounded part of the bullnose, and the base coat got too thin, and it was subject to deterioration and cracking. So you only know that by profiling it. See, it's 0.8 up here and 0.2 there. So observation of flashing, end dams, laps and splices, termination, top, bottom, and corners, integration of the flashing, underside of the flashing, is it adhered? Can you bypass it? Can you blow underneath it? And drip edges. One question is not up there. Is there flashing? If there is flashing, these are the things to look at. If there is no flashing, that's what you need to look at. I think, this is the type of crack you see when there's inappropriate alignment of board joints aligned with window openings. You see cracks like that. I'm going to go through these fast. This was interesting. This was a motel. And we're going to, the complaint was the windows leak. There's water in the building, the windows leak. So we're going to test the window. But we're going to test the window and not wet the eaves. We're not going to wet the eaves. We're only going to test the window. So we're masking the eaves all around. So only the window gets wetted. There's the chamber in place. Yeah.
So you don't want to get anything wet. Instead of water, can you use smoke?
No, because the smoke doesn't respond, doesn't fill up tanks, and it doesn't respond to gravity. So I really want to see what the window does. Okay?
So then for your, what you're doing from the outside, instead of building a chamber, did you go to the access door in the wing and put a blower door?
Yes, but I would still have to mask the eaves, so I didn't wet the, I don't want to wet the eaves. That's why we're doing it outside. And I'll show you the reason why. This is below the window. This is below the window. And it's got running water on it, and we're not wetting the eaves. Now, how can that be? Coming from the window. Yeah, definitely the window leaks. And here I pulled up a piece of EPS board to inspect under a feature someplace else on the building, and this is the ribbons I saw. What do you see in that ribbon? What does that ribbon tell you? Well, it's gapped, yeah, but that's not that alone. Some systems are gapped. How much EPS bead got stuck to the adhesive? Didn't hardly stick at all, did it? There's only a couple of beads here and here stuck to the adhesive. Okay, I think I'm going to stop there because some of this gets a little stale. Okay, that's it. Any questions? My recommendation is to get a copy of E2128, a copy of E1105, and join ASTM and participate in the standards writing process. It'll be an education, and you'll meet a lot of great people, wonderful people. who I consider my friends.